Good day, everyone. Welcome to today's session. In this session, we will be covering Topic 2, Advanced Monitoring and Diagnosing Network, Module 2, Machine Learning in Anomaly Detection. My name is Aini Othman, and I will be your instructor for this session. For this session, we will cover on three subtopics. First, the role of machine learning in cybersecurity. Next, example of AI-powered anomaly detection tools. And third, challenges in implementing AI-driven solution. And here are our learning outcomes. After this session, you will be able to explain the role of machine learning in enhancing cybersecurity practices. Second, you will be able to evaluate AI-powered anomaly detection tools and their effectiveness in identifying cyber threats. Third, identify the challenge and considerations when implementing AI-driven solution in cybersecurity. The role of machine learning in cybersecurity. Machine learning is transforming the field of cybersecurity by enabling systems to detect, respond to, and predict potential security threats in real time. By processing and analyzing vast amount of data, machine learning algorithm can identify patterns and anomalies that may indicate malicious activity, often before these threats can cause significant harm. This proactive approach allows for a quicker response, reducing the time it takes to mitigate risks. Unlike traditional rule-based security systems, which rely on predefined rules to detect known threats, machine learning systems continuously learn from new data, adapting to emerging threats. As cyber attack evolve, machine learning models can identify previously unseen patterns, making them more effective at detecting unknown risks. This dynamic adaptability makes machine learning an essential tool for improving the efficiency, accuracy, and overall effectiveness of cybersecurity defenses. Supervised learning for anomaly detection. Supervised learning is method where machine learning models are trained use labeled data, meaning the data has been pre-identified as either normal or anomalous. This label data allow the model to learn the distinguishing features between these categories. In the context of cybersecurity, supervised learning can be particularly effective in detecting known threats by recognizing patterns of behavior that have previously been classified as malicious or abnormal. For example, it can be used to identify malware signatures, known phishing attempts, or unauthorized logging activities. Once trained, the model can apply this knowledge to new unseen data, help to detect similar behaviors, and classify them as either normal or anomalous. Supervised learning algorithm used for this type of anomaly detection include decision trees, which classify data based on specific criteria, and logistic regression, which predict the probability of an event based on input features. These algorithms are particularly useful in situations where threats exhibit consistent, identifiable patterns, making them valuable tools in cybersecurity for detecting known risk. Unsupervised learning for anomaly detection. In unsupervised learning, the machine learning model does not use label data. Instead, it analyzes data and tries to understand what is normal based on pattern it finds. By recognizing this pattern, the model can identify anything that looks unusual or different from the normal behavior, which is known as anomaly. This type of learning is especially useful for detecting new types of cyber attack like zero-day attack, which have never been seen before, or insider threats, where a trusted person may act maliciously but does not follow known attack pattern. Some common algorithms used in unsupervised learning for anomaly detection include k-means clustering, which groups similar data points together and identifies those that don't fit the group, and encoders, which are a types of neural network that can learn a compressed version of the data and spot anomalies by looking at data that doesn't fit the usual pattern. These algorithms help in finding unusual behavior that might indicate a security risk. Okay. Next, we look on semi-supervised learning. Okay, semi-supervised learning combine both supervised and unsupervised learning technique using a mix of labels and unlabeled data. This approach is especially useful when there is not enough label data to train a model effectively, but large amount of unlabeled data are available. The model learns from the labeled data, but also tries to identify patterns in the unlabeled data, improving its accuracy and generalization. A common use case for semi-supervised learning is in fraud detection system, where label example of fraudulent transaction may be limited, but vast amount of transaction data are available. By using semi-supervised learning, the system can make better prediction by learning from both the small set of labeled data and the large set of unlabeled transactions. This technique allows system to detect fraud more accurately even when it's hard to get many label examples of fraudulent behavior. Common algorithm used in cybersecurity. Common algorithm that used in cybersecurity help detect anomalies and threats in data. Clustering algorithms such as k-means group similar data points together, and anomalies are identified as data points that do not fit into any group called outliers. Neural networks are more advanced models that can learn complex patterns in data, allowing them to detect intricate anomalies that simpler models might miss. They are useful for identifying complex threats like sophisticated malware. Support vector machines, SVM, work by finding the best boundary or hyperplane that separate normal behavior from anomalous behavior. This help in accurately classifying data and identifying threats. These algorithms are essential in cybersecurity because they enable systems to detect known and unknown threats, improving the accuracy and effectiveness of security system. And diagrams of this algorithm show how data points are grouped or separate to highlight anomalies and improve detection. Benefits of machine learning in anomaly detection. Machine learning offers several key benefits in anomaly detection. First, Machine learning enables adaptive detection of evolving threats. As cyber attacks become more sophisticated, machine learning models continuously learn from new data, improving their ability to identify emerging risks. This adaptability helps protect systems from unknown or evolving threats that may not fit traditional patterns. Second, machine learning reduces the need for manual monitoring. Traditional monitoring requires human intervention to analyze the data, which can be slow and error-prone. With machine learning, automated system can process and analyze vast amount of data in real time, significantly increasing efficiency and reducing the burden on human analysis. Finally, machine learning leads to improved response time. Since machine learning models can detect anomalies quickly and accurately, they allow for faster identification of threats. This enables organizations to respond to and mitigate risks more swiftly, minimizing potential damage and enhancing overall security. Next is the example of artificial intelligence-powered anomaly detection tools. AI or artificial intelligence powered tools leverage machine learning to process and analyze large volume of network traffic and logs. These tools are designed to handle vast amount of data quickly and efficiently, identifying patterns and potential threats that might go unnoticed by traditional systems. By using advanced algorithms, artificial intelligence tools can detect anomalies and malicious activities in real time, allowing for immediate action to prevent or minimize the damage. One of the key advantages of artificial intelligence-powered tools is their ability to provide actionable insight. This insight helps cybersecurity teams understand the nature of the threats and its potential impact and the necessary step to address the activities. This makes it easier for security teams to respond quickly and effectively, reducing the risk of security breaches. Overall, artificial intelligence-powered tools are essential in modern cybersecurity, offering fast detection, improved accuracy, and the ability to adapt to new and evolving threats. Next, we go to the Splunk. Okay, this is one of the powerful tools. Okay, Splunk is a powerful tool designed for monitoring and analyzing machine data, such as logs, metrics, and system performance information. It helps organizations make sense of a vast amount of data generated by their networks and systems, providing insight into operational and security-related issues. Splunk uses machine learning models to detect unusual patterns in data, such as unexpected spikes in traffic or abnormal system behavior, which could indicate security threats. This machine learning model allows Splunk to automatically identify potential anomalies that may be missed by traditional monitoring methods. Additionally, Splunk integrates seamlessly with existing cybersecurity workflows, enabling automated threats detection and response. This integration helps organizations take faster action in mitigating the risk. Splunk is especially ideal for real-time monitoring of network traffic, as it can quickly identify and alert security teams about potential security breaches, allowing the swift intervention and protection against evolving threats. Second tools, we have ELK Stack, Elasticsearch, Logstash, and Kibana. The short form will be ELK. ELK Stack is a powerful open source toolset that helps with data indexing, visualization, and monitoring. It is widely used to process and analyze large amounts of data from different sources, making it easy to search, view, and understand complex data. The ELK stack has custom anomaly detection features, which can be aided through various plugins, and these allow users to tailor the system to detect specific types of unusual activity based on their needs. Additionally, it offers flexible monitoring capabilities for network data and logs, allowing users to track the performance and security of their systems. This ELK stack is especially useful for identifying log anomalies and monitoring server activities. It helps in spotting abnormal behavior or potential threats within logs and network traffics, making it a valuable tool for maintaining system security and operational health. The third tools we have is Darktrace. Darktrace is an artificial intelligence powered security tools that use an enterprise immune system approach to detect anomalies by monitoring network behavior in real times. It continuously observes the network for unusual activities or potential threats, much like how the human immune system detects and reacts to foreign invaders. Darktrace monitors user behavior across network and system, allowing it to spot abnormal activities. It is also adapt autonomously to new and evolving threats, constantly learning from the network environment. This helps the system stay effective as cyber threats change over time. Darktrace is particularly useful for detecting insider threats or lateral movement within network, which may be difficult for traditional security system to catch. Its ability to learn and evolve make it valuable tools for identifying subtle or new types of attack. So this is the comparison of the three tools, Splunk, ELK Stack, and Darktrace. Highlighted here, each tools offer unique strength, with Splunk focus on analytic, ELK Stack being open source and customizable, and Darktrace excelling in behavioral analysis and adapting to new threats. So each have their own specialties. Next, we go to the example of real-world application. Okay. Artificial intelligence powered tools such as Splunk, ELK Stack, and Darktrace have become essential in a variety of industries to enhance both security and operational efficiency. In healthcare, these tools play a crucial role in protecting patient records by detecting unauthorized access or breaches, ensuring compliance with privacy laws like HIPAA. This helps maintain patient confidentiality and trust in healthcare system. In the finance sector, artificial intelligence tools are used to detect fraudulent transactions such as unauthorized account access or abnormal spending and monitor financial irregularities. This helps prevent fraud and ensures the integrity of financial system. For government agencies, these tools help monitor sensitive data traffic, detecting potential breaches or cyber attacks. By preventing data leaks and safeguarding critical infrastructure, they support national security. In all these industries, artificial intelligence powered tools are instrumental in maintaining security, ensuring privacy, and improving operational efficiency, keeping organizations safe from evolving threats. Next, we go to challenge in implementing artificial intelligence driven solution. First, we go to overview on the challenge. Artificial intelligence powered tools in cybersecurity through though highly effective also prevent some challenges. One key issue is false positive, where the system mistakenly flags legitimate action as threats. This can cause unnecessary alerts, leading to waste time and resources. Another challenge is data bias. If the data used to train the artificial intelligence model is incomplete or unbalanced, it can lead to inaccurate conclusion, causing the system to miss important threats or misidentify them. Lastly, high resource requirements can be a problem. Artificial intelligence tools require significant computing power, storage, and specializing expertise to manage and operate effectively. This can make them costly and difficult to implement for smaller organizations. Despite these challenges, with proper management, artificial intelligence tools can greatly enhance cybersecurity efforts. Okay, false positive in anomaly detection. One of the main issues with anomaly detection system is false positive, and this occur when the system mistakenly flag normal behavior as abnormal, even though there is no real threats. For example, if a user accesses their account from a new device, the system might think it's suspicious and raise an alert even though it is legitimate. The impact of false positive can be significant. It leads to alert fatigue, where security teams become overwhelmed by constant false alarm. This can result in wasting time and resource on non-issues, which reduce the team's ability to focus on real threats. Over time, false positive can also decrease trust in the system, as people may begin to ignore or overlook the alerts. To address this, fine-tuning machine learning model is essential. Contextual analysis can help understand the circumstance behind action, and adjusting threshold can help ensure only genuinely abnormal activities are flagged. These steps can reduce false positive and improve the system accuracy. Next is data bias. Data bias issues this can be concluded as a major issues in machine learning, as this data bias, which occur when models are trained on incomplete or biased data. This can lead to poor performance, especially in environment that are more diverse or different from the data the model was trained on. For example, a model trained primarily on data from North America may fail to recognize or detect region-specific threats in other parts of the world, such as unique cyber attacks that occur more frequently in Asia or Europe. The impact of this bias can be serious, as it could lead to missed threats or incorrect conclusion in certain regions. To solve this problem, it is essential to diversify training a data set to include data from various regions and contexts. Models should also have broad representation of different scenarios to ensure they are well-rounded. Finally, extensive testing across different environments is key to identifying and fixing biases, making the model more reliable and accurate. Implementing cost and expertise. Implementing artificial intelligence powered tools in cybersecurity can be expensive and resource intensive. Artificial intelligence tools require significant computational resources such as powerful servers, storage, and specialized hardware to process and analyze large amounts of data in real time. Additionally, effective implementation and maintenance of this system demands skilled personnel with expertise in machine learning, data analysis, and cybersecurity. Finding and retaining such talent can be costly for organizations, especially for the smallest one. To address this challenge, organizations can leverage scalable cloud-based platform. This platform allow businesses to access powerful computing resources without needing to invest heavily in physical infrastructure. Cloud service also offer flexibility, allowing companies to scale resources up or down based on need, which can help reduce the cost. Another solution is to invest in training for in-house teams, enabling them to develop the necessary skills to manage artificial intelligence tools. Additionally, companies can partner with artificial intelligence vendors to gain external expertise, ensuring that their artificial intelligence systems are implemented and maintained effectively without the needs for extensive internal resources. As a conclusion, machine learning plays an important role in detecting network anomalies and improving cybersecurity. It helps system adapt and scale to new threats, making them more effective in real-time detection. Tools like Splunk, ELK Stack, and Darktrace are widely used in many industries to monitor network traffic, detect potential security breaches, and protect sensitive data. However, there are challenges such as false positive, where normal behavior is flagged as unusual, and databases which can affect the accuracy of detection. This challenge needs to be addressed for these tools to work effectively. And that's all for Module 2. We will continue our session on secure network design principle in Module 3. Thank you.